For micro-dispensing, there is one product line that is proven and trusted by manufacturers in semiconductor packaging, electronics assembly, medical device, and electromechanical assembly the world over. DL Technology, superior pumps and needles for the finer things in life.
Welcome to the Goepel booth here at Productronica. I'm joined by Ricardo Wenzel, who's the team leader for the Gascon Galaxy, which is the latest in the Gascon system of software. So welcome, Ricardo, nice to see you.
Welcome.
Okay. So tell us a little bit about this, the Gascon Galaxy system. It's got a whole battery of different tests inside it. What are its capabilities?
So of course we have started with plain boundary scan in the past. So you can add all kind of boundary scan tests, making interconnection tests, making RAM tests, also flash programming with boundary scan of course. But meanwhile, since over 10 years we are much more in boundary scan. So people call, for example, boundary scan plus. So boundary scan plus means using emulation technologies like processors, like FPGAs, to use them as a test centrum to expand the tests. For example, making faster flash programming, making high-speed test, for example. So it's also increasing much the coverage, because sometimes you can just use an FPGA to test interfaces where there is no other possibility to test these things. And this is all our head from system Gascon.
Right. So it's got a full range of tests. It's going to boundary scan, flash programming, functional test, and a whole range more. Now they can be represented, I guess, on the test analyzer that you've just introduced. Can we have a look at that?
Sure. So basically we can directly jump in the test coverage analyzer. So the new thing is you're seeing all tests which are involved, and you can dynamically just activate and deactivate them, so you don't have to create a plain static sequence. You can interact with it, adding tests, removing tests, see how the test coverage is changing, for example. We have extended our database, so Goepel always don't say it is tested or not tested. We are delivering you the information what we have done with all the elements on your board. Mm-hmm. So for example, pins, what tests are doing which information and which coverage to the pins. And the user is plainly defining his test statement. So he has a complete list of able definitions for test coverage groups, we call it. Mm-hmm. And one group could be, for example, tested. And the application engineer is able to define exactly the statement with the complete Boolean algebra, what means tested for him. That is very important. If you have circuits on the board where plain boundary scan is enough, so making static tests, but where, for example, high-speed circuits on the board where we want to, or you need dynamic testing or up to stress testing using our other technologies.
Right, right. So these different colors on this pie chart here are showing the tested areas and the different sections that you can group them into.
Correct. You can have unlimited groups, unlimited colors, so all what is possible, and you can define, in principle, your test coverage analyzing.
Right. Okay. So you can now take this forward now to a visual project explorer. This is the latest thing that you've introduced. Tell us a bit about that.
Okay, so we are trying to visualize all abstract data we have in Gascon. That starts with a tester view, where we can see, for example, our ScanFlex controller, and then your board, your target under test. And your target under test can, for example, be multiple boards which are connected to each other. Mm-hmm. And we having since years this information and these possibilities in Gascon, but in plain lists or tables. And now we are starting to create a graphical user interface, mm-hmm. so that you can see the boards, for example, in your project and how they are connected. Also the abstract scan path. So what is the scan chain of boundary scan? Now we can visualize it, you can interact with it, manipulate it, for example. And this goes much further until device clusters, which are going over the bound of a board. So multiple boards, how are these device clusters connected to each other, and removing things you are not interested in. For example, here in this view, we just have the plain ICs, the plain IC devices, removing all resistors and showing me if there is a connection between the devices or not.
Right.
So, and the final view is when the pin and net level, and here you are able to zoom in principle. So WebEx is an abstract theorem of zooming in and out of your complete test concept until to pin and net level, to down to pin and net level, and analyze also the connections between all elements. So there's no limitation. We could say, show me all devices and all connections of it, and you have a really big scene, and you can move through it basically.
It's a very comprehensive test system for sure. And it really goes down into the full detail of the test project. Where are you taking this next? What's the next steps in the development?
Yeah, okay, we are seeing that the boards are shrinking more and more, so that is good for us, for the embedded JEDEC solution department, of course, because you just need much less test access to execute our test suite in the end. And of course, many devices don't have boundary scan. But for example, a processor has a debug interface SVD. So we're having a new technology in the pipeline called emulation-based interconnection test, where we are using the GPIOs of the processor, for example, to making an emulated boundary scan interconnection test. So you can include this from your processor and other boundary scan devices in making an interconnection test, for example.
That's interesting. So it's like a digital twin of testing.
Yeah, it's increasing the test coverage. It was not possible before, now it's possible.
Wonderful, great. Well, it's great to see how the Gascon system keeps developing and expanding and becoming more and more useful. Ricardo, I want to thank you for telling us about it today.
Thank you very much too.